Okay, good. So we're gonna do what we're going to do here is we're going to do PyCharm, and look at my environment. Virtual environment now is different. So if you remember for my after this, I like to have virtual machines because if I don't want to have a software installed on my regular machine because I don't want to keep the files that are it's too heavy or too many files, then I just uninstall the virtual machine and it's much simpler to deal with those files to remove them. So in my local machine, my environment was the name of my environment for my project, and I have different environments. But this environment, I created it for this particular introduction to Python. So here, what I'm going to do is I'm going to create, if you want a new folder to organize your files, you go to your C drive, and you go to users, your domain, PyCharms, the name of your project, and inside you can create a new folder. So this could be week 3. Okay, so you can close that or minimize, and then you have a new folder inside your project where you can organize your code much better, because now here you can create a new file where you can create your code, your script, and then the IDE would be able to interpret it. So file is just for a text file. Python file is where you create your script. So if you notice, a lot of people have asked why we want to have the IDE if we already have Python, and why do you have Anaconda, why do you have to install so many things? And this is why. It's because you have the freedom to choose different environments to keep your codes and your projects very organized. So let's create a file here to script, so Python file, and then we're gonna call this week 3 code, so we don't get confused with our folder, and it's going to be an empty file. So we're gonna do what we did before. We're gonna import the libraries that we have, because so far we know how to install all the Python libraries that we would need through Anaconda, and how to use the IDE more or less. You definitely have to keep working on this IDE because it has a lot of content that we won't be able to cover in a single introduction. But the second week, we learned that you can use arrays and lists and tuples to create your databases and your information for vectors and matrices, and you can operate the vectors you can create a matrix and you can multiply them, you vector times matrix or vector times vector, using the linear algebra library. So let's go ahead and import what we have so far. So NumPy, and I'm going to import it as NP. So from now on, every time that I need a function from NumPy, I can use NP. So for instance, if I want to use cosine of 90, right now Python doesn't know what that is. But if I say NumPy, I say import NumPy as NP, and then I say NP cosine. Now he knows, Python knows what I'm talking about. You need the variable, the argument, and so on and so forth. Okay. We also import other libraries. So for now, we can start with this. One thing that I want to mention for those of you who are interested in using Python for calculus and linear algebra and mathematical and vector calculus, with Python, pretty much like in MATLAB, you can do symbolic computations. So symbolic computation, for instance, if you do x, say 3 times x plus 2 times x, and if you do this, you want to know that y equals this. So regularly, NumPy, which is a numeric library, you will have to say that x equals something. It could be a 1, it could be a 0.5, and the same here. This x that you assigned before, you can operate. So like if x equals 0.1, this now is not, you don't have an error. If you remove this, notice that you have a line here telling you that there's an error. You have here a warning and sign telling you that you have errors. And this is because if you were to do this by yourself, you know that this is 5x, but Python doesn't understand that at this point. Either you say that x is a number, and then you run your code like you would run it in C or C++, or if you want to do symbolic operations, what you need to do is that you need to import a new library, which is import SymPy. But look, SymPy is not, Python doesn't know what SymPy is. And that is because in our environment, we only installed NumPy and SciPy. SciPy is this one. SciPy is for scientific library. For symbolic library is SciPy. So let's go ahead and write this one. Import SciPy. So import SciPy as SC. But now we want to import symbolic library. So for that, we're going to have to create, or not create, we're going to have to activate our environment and download the new library. And it's the same case for anything else. If you're wanting to do statistics, you just have to Google what libraries have good statistical functions or functions that let you do statistical operations, and you just go to environment, activate it, and download the library. So let's go to Anaconda. And notice that since I logged off, my environment is not active anymore. It's active from my IDE, which is PyCharm. It is because when I created my project, I called this environment. But remember, what I want to do is install a new library on my environment. So for that, I simply go to Conda and I say Conda activate, just like we did in the very first video. Conda activate, and then the name of my environment, which is capital P, capital Y, capital I, intro 38. So PYI intro 38 because of my Python 38. And then if you notice, now it's not base anymore, it's my environment. And now what we're going to do is install the library that we need, which is some symbolic library. So Conda, once you have your environment activated, you type Conda install and the name of the variable that you're wanting to install. So that library is called SYM, symbolic Python. SYMPY. Enter, and then you should be having the JSON installed. Just say yes, enter. It's capital yes, or doesn't have to be capital yes. And now we have successfully installed a new library, which is the symbolic Python. So you can close this, and when you turn off your computer and you turn it back on and you want to install a new library, the only thing you have to do is say conda activate the environment and then say conda install the library that you want to install, such as we said right here. And you can install more libraries if you need to. And then that's how you install new libraries for the environment, the current environment that you have. If you want to create a new project, then you create, as you guess, you can watch the first video again, or if you remember, we said conda create minus name, and then you give it a name. So you can create a second environment for a different project if you want to have different projects so that you don't have to keep adding files that do not correspond to your same project. So if I were to do a project here for statistics, I don't have to come to week 3 and add a bunch of code. I can create a new project where I don't have to mess with these libraries and these folders anymore. So from here, if you go to your IDE, PyCharm, you can say import and then SYM, and now you can have access to it, SymPy. And we're going to say that for shortcut, we're going to call it SIM as sim, symbolic. And every time that you say SEM dot, you can have access to a bunch of libraries. So one question that I got last week was, why do you have to say as something? And it's because this is just a shortcut. If you don't do that, then in order to access your libraries, you have to every time write SymPy. So if this is easier for you, then go ahead, but it's just simpler to have a very short acronym or a very easy way to remember your libraries. Okay, so now notice that if you were to write this again, oh, before that, I'm sorry. Now, Python is wondering what is X. So for that, we're going to say that, okay, X from now on is a symbol. So X equals sim dot and symbols, quotation mark, X. And now Python knows that if you were to print this, print, let's say this is equals to, comma, my argument. If you run this with Shift Alt F10, now Python knows that 3x plus 2x is 5x. And if this is not impressive enough, you can also do integrations and derivations with this. For example, if you want to say what is the derivative of x squared? So first thing is that x squared is expressed as times 2. So do not get confused with C and C++ and MATLAB, which x squared is like this. So this is not something that Python recognizes. This will give you an error. In fact, if you do x squared, let's say print x squared. Yes, Python does not know what the hat symbol means. So x squared is times, and I keep forgetting that sometimes, so I'm not sure why Python decided to go this way, but that's the way it is. And if you want to do the derivative of x squared, you simply do sim, which is accessing our symbolic library, differentiate, diff, DIFF stands for differentiation, and we want to do x squared. With respect to what? With respect to x. And then we can print this. So we can say that d, how do we want to do this? D x squared with respect to x equals to, comma, and the function. Let's run it. So the derivative of x squared with respect to x is 2x. So that is correct. And you can do something similar for integration, which is integral, let's say, integral of x squared respect to x with respect to x. Okay, so instead of diff, we need to call the function for integration, which, as you can imagine, is integrate. And that will give us x cubed over 3. So, and the way it prints is also the same way. We will print times because this is power. So this is a good way for you to practice integration. And I got a question about how to do cosine. So for cosine, we have to do symbolic cosine. So remember that NumPy has also cosine, but it's a numeric value. So if you do np.cosine of a number, this will give you back the cosine in radians of that number. But if you want to use the symbolic functions, you have to use SymPy. So for that, we're going to say, let's borrow this line, and we're going to say the derivative of sine of x with respect to x. So here, instead, we're going to do the cosine or the sine function, which sine is going to be found from the symbolic library, and sine of x. And then that will give you cosine. And the same thing, you can do integration. But notice that, as I mentioned, if you do NumPy, you'll get an error because NumPy only takes numeric values, not symbolic values. So yes, the argument is not supported. Okay, so if you want to do that, you can do SymPy. So you'll get an error, but so for symbolic, you just use same.sine, and in that case, you won't get the error. Okay, so if you want to plot symbolic expressions, you can do it by using the plot function, which is sim.plot. And in this case, you take the argument, let's say x squared, and then you have to say from where to where. So first of all, we're going to do the variable x, comma, from -10 to +10. And if you run this, you get your plot from your command window. Okay. But in order to get the plot like this, but notice that now I get the plot like this. How come before I was getting the plot on the console or the command window, but now I can get it like this in a fashion that I can edit, I can add labels, I can add a title, I can get the thickness, I can add a grid, because, and this part took a while, so I did it before hand, and now I can show you how to do it. So pause the video and let it install. For me, it took a few minutes. Hopefully for you, it's much faster. What you do is you activate your environment once again, and you download a new library, which is going to be a very useful library for you. So type conda install mat, M-A-T, plotlib. Again, conda install Michael Alpha Thomas plotlib. This will let you access the library command or the library functions to create this type of plots. So now by going to PyCharm and type in same.plot, you can create a bunch of plots that will be with a much higher quality. So this, and then you can do comma title equals 3x. Let me see, do I get an error here? No, very well. So you can add your X legend and your Y legend, and you can add labels. So this is much better. And you can say grid on, so on and so forth. So go ahead and install that library for your plotting, and let's go ahead and use that library for further plotting. So I'm going to comment this block with 3 quotation marks, and now I'm gonna use NumPy for showing you how to plot your data. So let's create a very simple file that, let's assume that you measured the power from your resistor, or that you measured the temperature for your system. So let's very quickly go to Excel. Oh, I don't have Excel on my virtual machine. No problem. Let's go to my original machine and let's go to Excel. And here, let's create a file that it will be, let's say, time. It's going to be every second. 1, 2, 3, 4. Let's say that we measure this for 60 seconds. So this will be the text file that you get from LabVIEW or from some system that you're using, Dataforth, Arduino, whatever, you're saving your data. And let's say that your time is that. Let's say that your temperature temp is, what could be your temperature? So that is, let's say, is this squared. And yeah, let's go ahead and say that it's squared. So okay, good. So this temperature is supposed to be random, but I don't have a temperature data with any temperature data with me. So let me save this file. So save as desktop, and it's gonna be temp dot. Let's say this is comma separated file. Okay, good. So if I go to my desktop, I am going to be able to find temperature as a comma separated file. It should be open with Notepad. Yes, so time, temperature, and then it's separated by a comma. Okay, good. So now what I'm going to do is that I'm going to go to my virtual machine, and I'm going to create a new file. So file, new file, and this is going to be temp dot comma separated file or text, it doesn't matter, and I'm going to save it like this. Okay, good. So I'm going to say that at the end, for instance, LabVIEW at the end gives you flag to tell you that the file is over, doesn't have any more line. I think is $sign. So I'm going to put the same thing that I usually get from, I think it's Dataforth or LabVIEW. But anyway, some files usually give you a way to know that your data is done. So this is a pretty common way to know that. So save that, close it, and we're going to start our code. Or actually, let's go ahead and get rid of all this, or create a new file, whichever you want. So I'm clarifying that since I don't have Excel on my virtual machine, I went to my regular machine and created a file on Excel. But if you have a temperature file that you want to read, or just create a file on Excel, a comma separated file, it's .csv, comma separated vectors. So the file, you can save it as, from Excel, you can save it as text or temp.csv, and then you can import that file into your PyCharm folder from users, PyCharm, your folder, or you copy the whole file with Control A and you paste it on a file here. But anyway, so let's go ahead and read that file, which you will learn more about read and write later in the more advanced class, but for now we just want to get the data into Python so that we can plot it and analyze it. So let's go ahead and do create our file or vectors. So we're going to need time, and this is how you allocate memory for vectors. Vectors. So we need a vector for time, and we need a vector for temperature. Okay, good. Then this is for time. Remember that this will give you a comment. So a comment is not executed or interpreted by your interpreter. This is for you to tell other people what your code means in case they don't know right off the bat. Temperature. Okay, good. So we have started our vectors, and we're going to open the file. So we're gonna say that the title of my file is temp.txt. Let me run this and see if I get any errors. And I don't get any errors. Okay, so I'm accessing temp.txt. Good. So let's go ahead and read the file. So first I'm going to say file equals open, and open is a function from Python. So my title or my file temp.x, remember that I am assigning this string to this. So Python is recognizing that something called temp.txt contains some data in a string format. So for now, and this is important, this is strings, string. Inside temp.txt, I have strings. Not, to me they're numbers, but for Python at this point they're just strings of letters or characters. And I'm going to say read the file. So again, if you run it, you should be able to have no errors. If at some point here you have any errors, make sure that you're writing exactly the name of the file. The errors here could be that your name here does not correspond to the actual name, or you have a space, or you have it as .csv.text. So make sure that this name is the same name that you have here, and this title is the same title that you're copying here. So make sure that everything is exactly the same. Not exactly the same as I have it, but exactly the same as your lines. So title here should be title here, no capital, and text, temp.text should be the name of the file that you want to read. Okay, let's move on. We're going to read the first line. So I'm going to say my first line is equal to file dot read line, and Python knows that I'm going to read a line. So this is a function in Python, and if I print this line, I should get the title of my file. Yes, I mean the first line of my file, time.temp. Very well. So if I go to my file, I get that the first line is just the title. I don't need this for anything because I'm calling my vectors T and T, capital T. So I don't need for anything. I'm just gonna keep writing. I'm gonna keep reading my line. So I'm gonna say, we need to read everything until the very end. So let's go ahead and use a while loop. Where's my code here? So how do we do that? Let's go ahead and check what line is. So line is a string, as you know. So if I say line at position 0, I get a small t. Why? Because I have time, so 0, 1, 0, 1, 2, 3, 4. So at 4, I should have a comma. So you see what I'm getting at, right? This line is a string which has a bunch of characters. So what I want to do is that I'm going to say, if I read a line, or while my, let's go ahead and read another line. So let's go ahead and read a line here. So this should be my next line, which my next line is 1, 1. So I'm going to read every line. So I'm going to say while line at position 0 is different than the flag from my data acquisition system column, do what? Read another line and print that line. Print line. Let's see what we get here. All right, good. I like it. So I am getting every line, and I'm stopping at the end of the file. Let's see if I'm getting any errors. I doubt that I'm getting errors because no indentation here, and say end of file. End of file. Okay, good. So let's close the file, file.close. And now I have that file done. So now I can read the files and use them for what I want to do. So in this couple of lines, I'm reading all the lines from my temperature. And this could be thousands of lines. In fact, if your temperature file or your pressure file or your power file or whatever file you want to read doesn't have a flag or something at the end, you can add it so that it's easier for you to read it. If not, you're gonna have to say, if you don't have a flag, then you have to be smart about it, because you have to say, okay, there's an end of line here or end of file. So there's a way to do it, but that's why when you read a file from LabVIEW, usually gives you a flag that tells you that that's the end of the file. Okay, so now let's go ahead and take that line and turn it into something that we can use. So let's go ahead and say x equals, or position equals line dot split. So let's go ahead and print position. This is a function that will let you split your line by the comma. So this should work like this. If you say that my time is which is my first, oh, but there's an error here. I'm not reading my time one. So I need to get rid of this line here. Let's see if I can do that. One, okay, good. So let's see, line position, let's say if I say t comma append int of position 0, position 0. Okay, good. And I say print t, what happens here? I get an error, and it's because what is my position 0? Get rid of this line and go back to position 0. So my position 0 is this whole thing. Oh, so it's not splitting anything. Nope. Okay, so position 0 is the whole string. Therefore, I need to tell my code to split it by a comma. So if I run it, I say line, oh, but quotation, line, split, comma. Okay, good. So my first is reading the comma from the first line, and I don't want that. Therefore, I'm going to start from the second line. So let's go ahead and add a line here. And I should start by 1. No, I'm starting by 2. Okay, so this is the part where I want to see. If I say t dot append, and then I do int parenthesis position 0. What happens here? It's telling me that it's telling me that it's reaching the last line and it does not understand what 0 is. Let me see something here. If I debug this code, I am going to get 1, yes, 1, 2, 3, 4, 5, 60. Okay, good. But oh, I understand why this is happening, because I need to read the line at the end. Okay, let's do it again. So yes, and then good. So what happens here is that I need to read the first line and the last line. So let's go ahead and do a debug here. And I am going to have my t start from 1 and then go to 60. Good. So then what I need to do next is get my second column to my temperature. So it's going to be the same thing, except for here I'm going to get temperature, and this is going to be my first or my second position on the vectors, right? Because if you go to the file, this is position 0 and this is position 1. Therefore, 0 is my time and 1 is my temperature. And if I were to print position 1, comma, position 0, comma, position 1, what do I get? Yeah, okay, good. Perfect. So what I want to do next is, after I close my file, I have those two vectors that are at the same length. So I should be able to say something like plot. Let's go ahead and import our plotting library. So we need to say import matplotlib dot pyplot plt as just simply plot. So import matplotlib.pyplot as plot. Okay, so here we're going to say plot those files by saying plot, comma, plot dot, and the function plot. With plt is because I'm calling from the import matplotlib. And now from that library I'm going to call plot, and that dot means from plt call the function plot, which I need parentheses because it's a function, and I'm going to say t, comma, t. If I run this, I don't get any errors. Okay, and to show the plot, I do plot.show. Run it, and there you have it. So is my time is in the x-axis, my temperatures on the y-axis. Now, one thing that you'll notice is that this was temperature. I know that I created this file from Excel, but this is supposed to be temperature from measurements. So the rule of thumb when you, and I'm sure you've seen this when you do your labs, when you take measurements, you don't show a solid curve, you show points. To show points, I like this option. So this is how you show, there you go. This is how you show that those were supposed to be experimental points, because then you can see what's the error. And furthermore, if you want to show what's the accuracy or how close they are, you can say plot and call the functions grid, and in my parentheses, and run it. There you go. So this is my plot with my grid, with my axis that I can label. So I can say plot.title, and my title would be something like time versus temperature, and the same thing for the X label would be plot. Every time you need a function from plot, you just say plt dot X label, and then parentheses, you're gonna say this is time in seconds, and I'm gonna do the same thing for Y. So plot Y, and this is temperature 3600, let's say Kelvin. This seems to be the temperature of a hydrogen atom, I don't know. Temperature. Run. Good. So, need to put this show underneath at all, otherwise it's not going to capture my execution order. There you go. Good. And you can look into the help for matplotlib. Then you can change the size, you can change the range, you can change the axis, the separation. This has a lot of options. If you have more than one plot, you can put it here, a second plot to plot. If you have more data, power, pressure, you can add it here, change the colors and add the labels. So this is how you can insert plots into your code. Now notice that when you run your code and you get the plot, you can save the, once you have this plot to the shape and form that you like it, you can save the figure as a JPEG or a PNG file. And you can make these plots pretty high quality actually. Okay, so a review of this part is that we are writing a simple file. You'll learn more about this on your advanced class. And for that, we simply open the file, we read the first line. The first line is my temperature and my titles. And then I actually don't need this anymore. Then I read my first line. So here I'm reading my first line, and it's going to be 1,1, which is my first data point. And then I'm saying, okay, now that I have my line, read every single line. And you can design this as much as you want it. This was a fast way to make it work. But I'm basically saying, okay, I'm gonna read every line until I reach my flag, which is the $sign. So for that, I took the values of my first line. Remember that the line is a string of characters. So I need to turn the what this is that position 0 is, once I do a split, this is broken into, hopefully you capture this part. Once I do split, I broke this string into two parts, the one before the comma and the one after the comma. If I were to have comma 6, comma 5, comma 3, then and all the way to the end of the flag, then split will give me 5 positions, 0, 1, 2, 3, and 4, because I'm saying split the string by the comma. So in this particular case, I only had 1, 1, so it's splitting it into 2, and is returning, I'm getting a vector where this is my first position and this is my second position. Therefore here, I simply have to say, okay, from position, which is a vector of 2 elements, I'm going to get my first element and call it time, because this is always the case. Before the comma is always the time, and after the comma is always the temperature. And append is a beautiful, very practical way to build your vector. So I'm simply saying, okay, this point added to my temperature vector. And of course, remember that there were strings, so if we want to add them or multiply them or do anything with them, we have to turn them into a number. Okay, so for instance, if they were 1.43, I'm sorry, 1.45, and then this was 0.43, and this was 0.6. If they were floating numbers, then you would say, instead of int, you would say float. Okay, let's save this and let's run this. Good. So now I'm having my first vector time is set of integers. My second vector temperature is floating numbers. And this is very practical because you can combine them later if you want. Python will let you do this. In C, Fortran, C++, that is not possible. So this is a very practical way of dealing with objects that are not the same nature or don't have the same attributes. I don't need this line now. So really, to read my file, I only needed this 7 lines. Okay, good. So that's how you plot your file, your temperature data. If you were to have more, you just do here the same thing, but instead of being position 1, you do position 2. You can add your files as much. You can keep this code and just change the type of your data or study this, and later on you'll be learning how to deal with reading and writing to files.
So, library that I wanted to show, I mentioned that those of you in mechanical engineering that have to deal with fluid dynamics and heat transfer and thermodynamics. In thermodynamics, you have the famous thermodynamic properties of fluids, of working fluids. So you have water, you have refrigerants, you have air, and is basically the table that gives you the saturation, liquid and vapor, and enthalpies and entropies of your substance at different temperature and pressure. And you know that with two states, you can find a third state. And if you go to coolprop Python or directly to coolprop.org, it will let you install a library for Python where the only thing that you have to do is download the library and you access the tables. So let's go ahead and do that. As you see here, you have to say conda install conda for coolprops. So I'm going to copy this and I'm going to go to my project. So if I open conda, Anaconda, and then I say activate my environment one more time. Conda activate capital P, capital Y, capital I, and throw 38. Okay, that's active. And now if I paste this, I should be able to download the JSON files for the library. Good, this is installed. So if you go back to the example, the way to install this is, and if you're a developer, if you want to add later on things, then you can also do the adding or be part of the coolprops project. So let's go and do an example for Python. So from coolprops, import props si. And this is an example that will let you see that basically is the same thing for many other things. For properties of materials, for electrical properties, you basically just have to find the library that somebody is developing or that's available. So from coolprops, import props si. Si is the units of International System of Units. And then say, this is how you use it. Density of carbon dioxide at 100 bar and 25 degrees Celsius. So let's see what happens here. So let's go ahead and here after I read my file here, or no, even before anything. So if I say then CO2 equals. Now notice that I have access to my library. If I run it, I'm sorry, I need to run the right project. If I run it, let's print this. So here's when you're debugging, it will show you the value. So 800, 17.62 kilograms per meter cubed. But let's say print density of CO2 at 298.15 Kelvin. The input, I'm gonna go through the input of the function in a minute. I'm just gonna write this at this pressure in pascals is, let's go ahead and rerun it. So what do we get? Okay, good. So the density of CO2 at 298.15 Kelvin and 100 e to the 5 pascals is, yeah, this is where I probably have to say density of CO2 there you go. So it's A17.62. And if you want to add the units, that is even a better idea. Kilograms per meter cubed. Very nice. Which I think that's what we get at the page. So the way, yes, the way you use this function is, so props SI is the function that lets you access the tables of properties in thermodynamics. The first argument is what you want to find. So in this case is the density, but it could be the entropy, it could be the temperature, the pressure. It's just for those of you taking or that took thermodynamics, you will capture this pretty easy. And then this is the variable that you want to find, so the density, and the attributes are based on temperature, and input the temperature in Kelvin. And the second argument is, in this case, pressure at CO2. Though you can have temperature and enthalpy, or you can have pressure and density and find these entropy. So this is a very, very powerful library for thermodynamic properties. Let's see one last example here. For instance, here's going to give you the saturated vapor enthalpy of refrigerant 134A at 25 Celsius. So this is how you do it. Enthalpy at a temperature of 25 C plus 273.15 Kelvin, so in 298.15 Kelvin, at a quality of 1. You can have a quality of 0 when you're fully vapor, or a quality of 1 where you're fully liquid, or somewhere between 0 and 1, which is a percentage of your multiphase flow. Let's see if they have a plotting example. So let's go ahead and try to plot this. So we already have the plotting function, so we should be able to do this one too. So let's go ahead and do this one next. But we need to take this one to the libraries. So instead of doing this one, I'm going to put coolprops plot. Very well. Good. And if you plot here, we're gonna see the properties of refrigerant 299 on the faces. And we're gonna find the isolines. Okay, so there you have it. We have pressure on the y-axis, enthalpy in the x-axis, and this is the diagram for the refrigerant 290, and these lines are iso enthalpies and isothermal. So this is a way, and you can access the properties of this table by typing your props SI.